Hi, today we're going to talk about the properties of exponents, and this is from section 5.1, and there are about 5 different properties that we're going to look at today. The first one we're going to take a look at looks something like this. If I had x to the second times x to the third, okay, well I know x to the second is x times x, and x to the third is x times x times x, there's 3 of them. Well, if I multiply those, how many total x's do I have? That's 5 x's, and 5 x's, and I can rewrite that as x to the 5th power. Okay, and you'll probably see a little bit of a pattern here. Okay, let me do one more here, and we'll see if we can make a conclusion. Okay, if I have a to the 4th times a to the 2nd, well, a to the 4th is 4a's, a to the 2nd is 2a's. If I add them up, I have 6 total a's, so I have a to the 6th power. Okay. And you're kind of seeing a little pattern here. What are we doing with the exponents? What's the relationship between 2, 3, and 5, 4, 2, and 6? We are adding the exponents. Okay? It can do it on variables. It can also do it with just regular numbers as well. Let's scooch this up here a little bit. Okay? One more here. Okay? What if I had 5 to the 4th times 5 to the 3rd? Okay? It's not 25. The 5 stayed the same, but it's 5 to the 7th power. Okay? Again, we add the exponents together. Okay? So I'm going to keep track of a couple over here. And I'm just going to write the first one down. If I have x to the 2nd times x to the 3rd, we have x to the 5th. And what I did with those exponents is I added them. Okay? So there's our first property of exponents. Okay? Not too terribly bad. Okay? The second property of exponents that we're going to take a look at is, what if I had x to the 2nd and I raised it to the 3rd power? Okay? It's a quantity raised to a power. Well, this little 3 up here means I'm going to multiply something together 3 times. That's what it means to cube something. What am I going to multiply together 3 times? It's whatever is inside the parentheses. So I have an x squared, an x squared, and an x squared. Okay? And if I use the same rule that I did over here a minute ago, x to the 2nd times x to the 2nd times x to the 2nd, if I add those together, I get x to the 6th power. Okay? And you probably see a little relationship between that and this. Okay? And you're exactly right. We multiply the exponents. Okay? And for me, the easy way to remember when you multiply versus when you add is whenever you see parentheses and an exponent on the outside of parentheses, that's going to be multiplication. And it's kind of like this. If I have 5 parentheses 2, that means 5 times 2. Okay? If both numbers are in parentheses, again, it means multiplication. Okay? And you've seen this before, the distributive property. Again, if I have parentheses, I distribute through. Okay? So whenever you see an exponent on the outside of parentheses, we're going to multiply it. Okay? And I'm going to add that one over here. Okay? Here's the second one. It's kind of x to the 2nd raised to the 3rd. It's x to the 6th power. And what I'm doing here is I'm multiplying the exponents. Okay? Now there's a couple extensions of this little property. Okay? What if I had something that was like 2x squared y cubed, and I raised it to the 4th power? What if there's more stuff on the inside of the parentheses? Okay, well, we do the same thing. This number outside, it just essentially distributes to everything. Okay, and right now, remember, the exponent on 2, there isn't one there, but it's a 1. Okay, so it becomes 2 to the 4th power, okay, x to the 8th power, and y to the 12th power. Okay, it multiplies all the exponents. Okay, now one common mistake is that, or let me back up. Whenever we have a number raised to a power, okay, let me say that again. Whenever I have a number raised to a power, let's evaluate that. Let's find out what that's equal to. And you can use your calculator. That's probably the easiest way, or a lot of these you'll just become familiar with. Now, 2 to the 4th power is not 8. It's 2 times 2 times 2 times 2. Okay, and that's 16. Okay, so anytime we have a number to a power, let's multiply it out. Okay, and then x to the 8th, y to the 12th. Okay, but what I'm ultimately getting at here again is when there's a number on the outside, it distributes to all the other exponents. Okay, and so maybe I'm going to write something like that here too. Maybe I'll write that exact same one. 2x squared y cubed to the fourth. Okay, it gets distributed to everything. And notice how I draw these little arrows here. I guess I should have done on that one. Okay, it becomes 16x to the 8th, y to the 12th. But once again, we're multiplying the exponents. Okay, and the third extension of this is what if there's fractions? Okay, what if I had something like this? X to the third over y to the fourth, and I squared it. Okay, and again, don't get scared by fractions, don't get nervous by fractions. We do the exact same thing. This exponent on the outside, it distributes to the top, and it distributes to the bottom. So it just goes to everything. X to the 6th over y to the 8th. Okay, if I take that a step further here, okay, what if I had more stuff? Maybe I had 2x squared y cubed over 5a squared, and I square it. It goes to everything on the top and everything on the bottom. Everything up there and everything down there. Okay, and what I oftentimes do is I treat the numerator and denominator separately. This would become 2 to the 2nd power, x to the 4th, y to the 6th. And then it also goes down to the bottom, 5 to the 2nd power, and a to the 4th. Okay? And then like I said a second ago, anytime we have numbers raised to powers, let's do those out. And 2 squared, 2 times 2 is 4, x to the 4th, y to the 6th. And 5 squared is 25. It's not 10, it's 25, a to the 4th. And that would be my grand finale answer there. Okay? So again, it's really that all of these are really just an extension of that second property here. And I'm going to add a third one up here. What if I had 5a squared over b and I cubed it? Okay? If it's a fraction, it goes to the top and to the bottom. Oops. It'd be 5 cubed a to the 6th over b to the 3rd. But once again, on all three of these, okay, we are multiplying the exponents together. Okay? So there's a second property. Okay? Another property that we're going to look at, okay, it's actually called the division property of equality. Here's the third one. What if I had x to the 4th over x to the 2nd? Well, remember, x to the 4th is 4 of them, x to the 2nd is 2 of them. Okay, and what can I do when I have x's on the top and x's on the bottom? I can cancel. Okay, if you look closely, I have 2 x's left over, and where are they? They're on the top. Okay? And yep, you see it here, it's subtracting the exponents. Okay? And what if I had this one? What if I had x to the 3rd over x to the 5th? 1, 2, 3, 4, 5. Again, 3 of them cancel out 3 of them. And this time I have 2 of them left. But where are the 2 left over? They're on the bottom. It's x to the squared, or x squared on the bottom, and we put a 1 on the top. Okay? I know when some people learned this in the past, they know to subtract them, and technically the formal rule is always the top number minus the bottom number. 4 minus 2 is 2. Okay? And then they would do 3 minus 5, and they would get x to the negative 2nd. Well, we'll see here in a second. We don't like negative exponents. We can't leave our answers with negative exponents in it. Okay? So we'll talk about how to fix that in a minute. But what I personally do is I just look at the numbers, and I always take the bigger number minus the smaller number. So 5 minus 3 is 2. And where are the 2 left over? They're on the bottom, so my answer is on the bottom. Okay? But it's simply just subtracting exponents. Okay? I'm going to erase here. Okay, so here's another one. The third property of exponents. Okay, this would be 1 over x to the 3rd. We subtract them. Okay, and again, it's just the bigger number minus the smaller number. And the answer is wherever the bigger number was. Okay, we'll look at more examples here in just a couple minutes. Okay, a fourth one, actually. So I mentioned this just a minute ago. What about negative exponents? We don't like negative exponents. Can't have negative exponents. Let's go negative second. Then I have a to the third, b to the negative fourth, something like that. Okay? And without giving you the big, long, boring explanation of this, here's how we make negative exponents positive. Well, first of all, let's go one by one. X to the fifth is okay. It's going to stay up there in the top. Okay? But y to the third is not allowed. And the way we make a negative exponent, if it's negative on top, we move it down to the bottom. It becomes y to the positive third on the bottom. Okay, it literally just changes place. Okay? Z to the negative second has to get bumped down to the bottom and becomes z to the positive second on the bottom. Okay? This a to the third, it's okay. It can stay down there in the bottom. But what about if it's negative on the bottom? Well, then it has to move up to the top and becomes b to the positive fourth on the top. So negative exponents aren't anything to be scared about or nervous about. Just note that we can't have negative exponents in our answer, and the way we make them positive is we move them up and down. Okay? Notice when I move them up and down, the number or the variable doesn't change sign. It doesn't become, it didn't become negative y to the third, okay, or negative z to the second, or negative b to the fourth. It's the exponent that changed sign. Everything else stays the same. Okay? What if I have this? What if I have a 3 to the negative 2 power? Okay, what if a number has a negative exponent? Well, can't have that up there either. That has to go down to the bottom, and it becomes 3 to the positive second on the bottom, okay, which we know is 9. So I'd end up with a 9 down there. But again, the 3 doesn't change sign. It's just the exponent that changes sign. Okay? And then how about the same thing? What if I had a negative 2 to the negative third power on the bottom? Okay? Well, I can't have a negative 2 to the negative third. It has to go up to the top. The 2 still stays negative, but the exponent becomes positive. And negative 2 to the third power is really, remember, it's negative 2 times negative 2 times negative 2 3 times, or you can use your calculator. But notice the negative sign is inside the parentheses. Okay? This would turn out to be negative 8, and I'd have a negative 8 in my answer. Okay? So again, negative exponents, just moving them up and down. And I'm going to write one little example here. 3 to the negative second x cubed y to the fourth over a to the negative second b to the negative fourth. Okay? And the things move up and down. This one goes down to the bottom and becomes 3 to the positive second. X to the third can stay put. Y to the fourth can stay put. But this guy's got to go up, and that guy's got to go up. So it becomes a to the positive second, b to the positive fourth. Okay? And I do have a number here, 3 to the second. I'm going to rewrite it as 9. And that would be my grand finale answer right there. Okay? So again, there's a fourth property of exponents. Okay? It's with negative ones. We just move them up and down to make them positive. Okay? They're not too terribly bad. Okay? And then I have one last one here, a fifth one. It's called the zero property. Okay? I'm just write that right over here also. Okay? And the zero property is really anything to the 0 power is 1. Okay? 5 to the 0 power is 1. 9 to the 0 power is 1. 4x squared y cubed to the 0 power is 1. Anything raised to the 0 power is 1. Okay, maybe I'll just write a couple examples. X to the 0 power is 1. And maybe anything to the 0 power is 1. Okay? Now there's one special thing to be careful with this. And what's the difference between this and that? One of them is 0 and one of them is not 0. Which one do you think is 0? It's the bottom one. Which one is equal to 1? This one is equal to 1. Okay? It's raising all of this stuff to the 0 power. That answer is 1. But if I look at the top one and ask myself, what's being raised to the 0 power there? It's just the x. Okay? So it's just the x that would turn into a 1, and that would turn into 5 times 1, which is 5. So again, once again, those parentheses make a huge difference. Okay? But again, anything to the 0 power is 1. Okay? All right. I'd like to take a look at 4 little last examples here, and we're going to try these. Okay, that some of them come, well, let's use them. Okay, here's the first one. Last 4 we're going to try here. What if I had 3x squared times negative 2x to the 5th? Okay, now I don't see any parentheses. I just see some multiplication going on. And when I look at this, I multiply big numbers with big numbers. So 3 times negative 2 is negative 6. And what do I do with the exponents? X to the 2nd times x to the 5th. I add them, and I get x to the 7th power. Okay, that would be that one. And that's the first property that I had up here a minute ago. It's adding the exponents. Okay, here's a second one. Okay, I have a little fraction. What if I had 4x squared over 5x cubed? Okay. Now again, the first thing that I always look for is I always look for parentheses. I look to see if I can multiply or have to distribute through. What? I see some here. I see this 2 right here. Okay. And notice that 2 is on the outside of the parentheses, but it's only in the numerator, so it's only going to distribute to the top ones. Okay. And when I get here, when I do that, I end up with 4 to the 2nd power and x to the 4th power. I'm multiplying exponents over 5x cubed. Okay, so there's nothing I could do in the denominator. Well, I can take it one step further. What if I simplify? 4 to the 2nd power, it's not 8, but it's 4 times 4, 2 times, it's 16, and then 5. What I oftentimes do is I treat the big numbers and the variables separately. So look at the 16 and the 5. I can't reduce them. I can't simplify them. I'm done. Okay, but what about these 2 guys? If I have x to the 4th over x to the 3rd, there's 4 x's on top, 3 on the bottom. I subtract them. 4 minus 3 is 1. And where's that 1 left over x? It's on the top because the bigger number's on the top. So I just get an x or an x to the 1st. And there would be my answer right there. Okay? There's a second one. Okay? Here's number 3. The third one that we're going to take a look at. Okay? What if I had x to the negative 3rd times 4y to the 6th over 2x cubed? I'm sorry, 2x to the negative 3rd to the negative 2nd. Okay? All right, let's take a look at this one. Okay, I see a whole bunch of stuff there. I see some x's, y's, I see positive exponents, I see negative exponents, I see parentheses. Okay, and to top it all off, it's a fraction. So holy cow, how are we going to manage all of that stuff? Okay, well, a lot of times when I see fractions like this, I'm going to do the numerator and the denominator separately. So I'm just going to look up here at the numerator. I see x to the minus 3rd. I see a negative exponent. Don't like it. Where does it have to go? It has to go down to the bottom, and it becomes x to the positive 3rd on the bottom. Okay, so that takes care of that one. 4y to the 6th, that's all good. Stays put. But when I look down here at the denominator now, I see an exponent on the outside of parentheses, so I have to distribute it. Okay, and it initially becomes 2 to the minus 2nd and x to the positive 6th. Okay, well, I can't have negative exponents. It has to go up to the top, and it has to become 2 to the positive 2 on the top. Okay, and notice that the base number 2 didn't change sign, it was the exponent. When I multiplied these, it became positive 6. Positive exponents are okay. It's going to stay down there on the bottom at positive 6. Okay, so I kind of got rid of the negatives and the distributing of the exponents all at the same time. Now let's simplify. If I look at my numerator, I have a 4, and then 2 to the 2nd, that's also 4. So 4 times 4, I get 16. Y to the 6th. Okay, that's my numerator simplified as much as I can. On the bottom down here, I just have some x's. X to the 3rd times x to the 6th is x to the 9th. I'm going to add them together. I don't see any more x's. You should only really have one of each letter. Okay, can't have more than one y, more than one x. That's all I got. There we got it. Okay, there's the third one. Okay, all right, I'm gonna try I got one last problem for us here. Okay, it looks like this. Here's number 4, the fourth and final one. Okay, I have a 3x squared y to the negative second, 4y cubed, x to the fifth, all raised to the negative second power. So here's one of these great big ones. Looks kind of big and scary. Okay, it's fraction, positive exponents, negative exponents. Again, let's try this one more time. Okay, I do see an exponent on the outside of parentheses, and this time the whole thing is in parentheses, the whole fraction is. So that negative 2 has to go to everything. It has to go here, here, and here to start with. I'm just going to start with the numerator. Okay, now I'm going to try to kill 2 birds with 1 stone. Watch this once. If I multiply my exponent, it becomes 3 to the negative second. Okay, and that's what I'm thinking in my head. Well, I don't like negative second power, so it has to go down to the bottom, and it becomes 3 to the positive second in the bottom, and 3 squared I know is 9. So I'm going to kind of do some multiplying, do the moving all at once. Not that you don't have to do it that way. It's perfectly fine to write each individual step. Okay? But that's how my 3. It ended up being 3 to the negative second, went to the bottom, which turned into a positive 9. How about my x? 2 times negative 2, that's x to the negative fourth. Well, I don't like negative fourth. I don't like negative exponents. It's got to go to the bottom and becomes x to the positive fourth on the bottom. Okay, so again, you can kind of do the multiplying and the moving all at once. But how about y? Negative 2 times negative 2, that's y to the positive fourth. We like positive exponents. It's going to stay up there in the top as y to the positive fourth. Okay, so that's how my numerator changed. Let's take this negative 2, and let's also put it down here to everything on the bottom. Okay, so down here in the bottom now, okay, if I have 4 to the minus second power, 4 to the negative 2, don't like negative 2 on the bottom, it has to go up to the top. It becomes 4 to the positive second on the top, and 4 squared is 16. Okay? Now again, if I did that too fast, too much, certainly write the individual steps. You certainly can. Okay? Y to the third, y to the y to the third to the negative second, that's y to the negative 6 if I multiply them. Again, don't like negatives, it's got to go up to the top and become y to the positive 6th on the top. Okay? And then the negative 2 with the x, it becomes x to the negative 10th on the bottom, 5 times 2. Don't like negative, it's got to go up to the top and become x to the positive 10th. Okay? So I kind of did all my multiplying of my exponents and all of my moving of my negative exponents all at the same time. And I simplified it here. Okay? Let's look at what I have left. And like I said earlier, I treat the big numbers and the variables separately. 16 and 9, 16 ninths. Is there anything that goes into 16 that can also go into 9? Nope, there isn't. Okay? So I'm going to leave it as 16 over 9. Okay? How about my variables? If I look at the top here, I have some y's. I have 4 y's on the top, 6 more y's on the top. I add them together, I get 10 y's on the top. Okay? And x's, I have some x's on the top, and I have some x's on the bottom. 10 on the top and 4 on the bottom. We subtract them. 10 minus 4 is 6. But where are the 6 left over? They're left over on the top. The bigger number's on the top, so I have x to the 6th power on top. Okay? So these properties of exponents, okay, sometimes we add them, sometimes we subtract them, sometimes we multiply them. Any negative exponents, we move up and down to make positive. Okay? And then, I didn't do any here, but anytime we have something to the 0 power, it turns into a 1. Okay? All right, there we have it. Give it a try. Good luck. Thanks for tuning in.